Hi everyone, today we're going to be going through factor theorem. So we'll start off with a couple of examples just to get the principles in our head, and then we'll do more of an exam style question so we're prepared for what we're actually going to see in an exam. Don't forget to like and subscribe if you enjoyed the video, and let's get into it. So what is the factor theorem? So the factor theorem allows us to find factors of a polynomial of any order and so solve the polynomial equation. So in short, that means if x minus a is a factor of the polynomial f of x, then f of a equals 0 and x equals a is a real root. So I know this sounds a bit confusing, but it'll become a lot more clear when we start going through our first example. So example 1. Prove x plus 2 is a factor of x cubed plus 5x squared plus 7x plus 2. So for those of you that watched the video on polynomial division, you'll see that we actually tackled this example in the previous video. So this is what we did. So x cubed plus 5x squared plus 7x plus 2 divided by x plus 2. It gave us an answer of x squared plus 3x plus 1. But the important part is that it gave us a remainder of 0. So this remainder of 0 tells us that x plus 2 is in fact a true factor of x cubed plus 5x squared plus 7x plus 2. So since it's a factor, that must mean that x equals minus 2 is a real root of this function. So what if we were to do f of minus 2? What if we were to substitute minus 2 into the function? What would we get? So let's do that together now then. So what we're going to do is we're going to substitute x equals minus 2 into the function. So let's write this out. So f of minus 2. So everywhere we see an x, we're just going to substitute minus 2. So minus 2 all cubed plus 5 minus 2 squared plus 7 minus 2 plus 2. So this will just turn into minus 8 because minus 2 all cubed is minus 8. Minus 2 squared is 4, times that by the 5 gives us 20. Minus 2 times 7 gives us negative 14. And then we got positive 2 on the end. So minus 8 plus 20 gives us positive 12. Minus 14 gives us negative 2. Plus the 2 gives us 0. So what this proves is that x plus 2 is a factor of this function. And that's because the remainder is 0. So whenever we're given a factor, we can take the negative of this number, substitute it into the function. If the remainder is 0, then we know that this is a true factor of the function, and then we can use that to perform some polynomial division and get the remaining expression. And with the remaining factors, we can figure out the real roots of the function, which is the main function of the factor theorem. So we'll go through an example now where we figure out whether a factor is a true factor of the polynomial, and then we use that to factorize the polynomial fully and therefore solve the equation. So here's example 2. So we've got prove x plus 1 is a factor of x cubed minus 4x squared minus 11x minus 6 and factorize fully afterwards. So the way we're going to prove it as a factor is we're going to take the negative of this in here. So the negative of plus 1 is minus 1. So we're going to say x equals minus 1, just like we did in the previous example. And then we're going to apply this minus 1 into this function here. So f of minus 1. Anytime we see an x, we replace it with minus 1. So we've got minus 1 cubed minus 4 times minus 1 squared minus 11 times minus 1 minus 6. So multiplying all of this out, minus 1 cubed is minus 1. Minus 1 squared is positive 1. Times by minus 4 is going to give us minus 4. Minus 1 times minus 11 gives us positive 11. And then we got minus 6. So minus 1 minus 4 is going to give us minus 5, plus 11 gives us positive 6, minus 6 gives us 0. So the fact that we got 0 here tells us that x plus 1 is a factor of this function because it means there's no remainder when we take out a factor of x plus 1. So now we have to go ahead and do the second part, which is factorize fully. So in order to factorize fully, we have to see what's left of this polynomial here after we take out a factor of x plus 1. So we can use polynomial division to do that. So let's get that all set up now. So here I've set up the polynomial division. We've got x cubed minus 4x squared minus 11x minus 6 divided by x plus 1. So this is the method to work it out. If you want to know this method in detail, then you can go back and check my previous video that goes through polynomial division in detail. So that will go through each individual step and how we go about getting each line. So what we're saying here is when we've done this polynomial division, we're left with this number on top, this function on top, x squared minus 5x minus 6. So what we're saying when we do this is we're saying x cubed minus 4x squared minus 11x minus 6 is equal to, so this is the original function, is equal to x plus 1 times x squared minus 5x minus 6. Right? Because if you were, just like you would in regular multiplication, if you were to do this number times this number, you'd end up with whatever's under this here. So we're doing x plus 1 times x squared minus 5x minus 6, but it wants us to factorize it fully, so we can't factorize x plus 1 anymore, so we leave that as is. But we can factorize this x squared minus 5x minus 6. So if we open up a double bracket, so to factorize this fully, we have to find two numbers that multiply together to give us minus 6 and two numbers that add together to give us minus 5. And those will be the two numbers that go here and here. So x here, and the two numbers are going to be plus 1 over here, and it's going to be minus 6 over here. So as you can see, we've got a plus 1 here, x plus 1 here, and an x plus 1 here. So of course we can bunch these together and say x plus 1 all squared, and then we've still got this factor of x minus 6. So this is the original polynomial fully factorized, and that's the answer to this question. So next we're going to be going through an exam style question. So here we are with question 6 from the 2017 FSMQ paper. So we've got, you are given that the equation x cubed minus x squared minus 10x plus 6 equals 0 has two non-integer positive roots. So non-integer means that they're not whole numbers, and one negative integer root, so that means it is a whole number. Part 1 is use the factor theorem, find the negative root, and then part 2 is hence solve the equation. So in order to do part 1, we're approaching it the same way we have done in the previous two examples. However, there's of course an infinite number of possibilities for x. So in the previous two examples, we found the roots by substituting in different values of x into the function. But usually we're given a factor to try out first, but this time we're not. So of course there's an infinite number of values that we could use. So how do we narrow it down? So we have to look at this plus 6 term. So what we do is we find the factors for this plus 6 term and then use those factors first in trying to find a root for the function. So that's the hint I'm going to give you for this. And then once you find that root, you can use that to factorize the function fully and then find the roots of the equation and solve the equation. So go ahead and pause the video, give it a go, and then come back to the video. Okay, so here's a solution to the question. Part 1, the negative root is negative 3, so x equals negative 3 is the negative root, and then to solve the equation you get x equals negative 3, or x equals 2 plus root 2, or x equals 2 minus root 2. So if you managed to get those answers, brilliant, fantastic, great job. And if you didn't, we're going to go through all the working out now. So part 1 of the question asks us to use the factor theorem and find the negative root of the function. So to find the negative root, we have to substitute different values of x into the function until we get a remainder of 0, just like we've done in the previous two examples. So how can we do this? Well, like I said before, we have to look at the factors of 6 to start with. So here are all the factors of 6. So since we know that we're looking for a negative root, we can look at these factors and immediately eliminate all of the positive integers. So now that we've done that, we just have to substitute each one into the function. So here's negative 1 as an example, and here are the others. So the one that we're really interested in is this negative 3 over here. So we can see that whenever we substitute negative 3 into the function, we get a remainder of 0. So this means, as we've shown in the previous examples, that negative 3 is a real root of the function, and therefore x plus 3 is the factor. So now that we have this information, we can move on to part 2, and part 2 asks us to solve the equation. Well, in order to solve it, we have to first factorize it fully. So to do this, we have to see what is left of the function after removing a factor of x plus 3. So in other words, we have to do a bit of polynomial division. So we have to take the original function and divide it by a factor of x plus 3. So let's do this now. Let's get that set up. So this is the question set for polynomial division. I won't be going through the full method here, but I do have a video on the channel going through this method in detail, so check that out if you're not too sure. So after we do the polynomial division, we end up with x squared minus 4x plus 2. So what does this tell us? Well, it tells us that the original function, x cubed minus x squared minus 10x plus 6, can be expressed as a product of these two factors. It can be expressed as x plus 3, all of it, times x squared minus 4x plus 2. So now that we have this, we can use this to find the remaining roots of the equation and therefore solve the equation. So like we worked out on the previous slide, we can express x cubed minus x squared minus 10x plus 6 as a product of these two factors, as a product of x plus 3 and x squared minus 4x plus 2. So in order to solve the equation, we have to consider these two factors. So let's do x plus 3 first. So x plus 3, and what we do is we equate the factor to 0. So x plus 3 equals 0, and then this one becomes pretty easy to solve. So already we have one of our roots, x equals minus 3. So then we've got x squared minus 4x plus 2, and we equate that to 0. So this one's a bit trickier to solve. We're going to have to do some further factorization here. So how do we go ahead and factorize it? So whenever we see something with this x squared term, we should immediately be thinking that we're going to go into double brackets. However, there's a clue in the question. The question tells us that we've got two non-integer roots. So whenever we see this non-integer, we know it's probably not going to go nicely into double brackets, because double brackets usually has whole numbers here and here, as well as the next term, right? So because it's non-integer, we're probably going to be looking to use this, the quadratic formula. So we've got to substitute our values of a, b and c into this quadratic formula, and that will give us our two roots. So let's figure out what a, b and c are. So a is going to be 1, because there's always a 1 in front of this x squared term. Our b is going to be negative 4. And our c is going to be this constant term here, which is plus 2. So now that we've got these values, we can go ahead and substitute into the quadratic formula. So we've got x equals negative of negative 4 plus or minus, so b squared is negative 4 squared minus 4ac, so 4 times a, which is 4, times by c, which is 8. So it's going to be the square root of all of that, all over 2 times a. So 2 times a is just 2. So we can go ahead and simplify this further. While negative of negative 4 becomes just 4, plus or minus, negative 4 squared is 16, minus the 8 gives us root 8, all over 2. Now we can use our rule of surds to simplify this even further. So we can do 4 plus or minus root 4 times root 2, all over 2. So of course this root 4 just becomes 2. And now we can divide through by 2. So we end up with 2 plus or minus root 2. So you can see these are our other two positive non-integer roots. So one of them is 2 plus root 2, and one of them is 2 minus root 2. So in other words, our answer to solving the equation is x equals negative 3, or x equals 2 plus root 2, or x equals 2 minus root 2. And that's the answer to this part of the question. So that's going to do it for today, guys. I am going to be releasing another video where we're going to be going through this question but using the comparing coefficients method. So keep an eye out for that. But other than that, thank you very much for watching, and keep an eye out for the next video. Cheers.